Okay, so I'm going to show you some examples made in Unity and games, and just take a minute, and then we're going to continue. Whoa, the screen looks a little bit different. Okay, that was better. Okay. I pressed the pause button. Okay, well, we'll see it later on the end. So, during this presentation, I will talk a bit about how to create playable environments in VR. And what the old things and what we learned from our community. Okay. So, I'm Callewaert. I work at Unity Technologies as a Global Director for Evangelism. And that means I work with a global team to make sure that we can educate the developers from today, people who are making no games to learn about, but also we want to find the new people, finding studios that we're not aware of, who are making great content, or we're going to make later on content, and work with you. So Unity has always has a philosophy of democratization. That means everybody should have access to the software. And just go to a website and you can download it. It's totally for free. We have more than we have about almost 6 million registered users. It's a huge amount of people. Our company likes to solve hard problems. And one of those hard problems is, how do you make AR and VR games easy? On the graphics side, on the performance side, and integration with SDKs. But also enabling success. Unity is the only engine that pays as the game developers. What does that mean? We provide ads. You can put advertising in your games, and that pays you. Who has used Unity ads? Nobody? So with Unity, we really love VR and AR. Okay. Now, you might have heard in the news, we recently got $180 million extra funding, and that is really something that we are putting towards AR and VR. And we strongly believe this is the future. Okay. Now, with Unity, there's a lot of games made. There's a lot of mobile games made, like Lara Croft. There's a lot of PC games made. And you might have heard of Space Code Program. They all use Unity. There's a lot of console games made in Unity. But now we're also heading in the AR and VR. And there's a lot of games made. Hey, Lucky Tail, for instance. Who has played Lucky Tail? Okay, so we have 2 people who play games. Was the rest is playing games? No? Don't work too hard. Okay. Budget cuts is made with Unity, enhanced in. Fantastic contraptions. Those are all AR and VR games made with Unity. But there's a lot of experiences also built. And it's not just about games. Okay? And that's why it is. I want to point this out. A lot of people think, oh, we have the video game industry. And now they're building on top of that VR and AR. And the reality is that we have to see it opposite, actually. That we have the VR and AR market, and a little spin of that is video games. There's a little spin of that is experiences. VR and AR is such a huge market that it's used in all different directions. Now with Unity, we also have partners. What does that mean? We work closer together with all those partners. Like we work together with Oculus, TeamVR, PlayStation, Microsoft, Gear VR, Google Cardboard, and Daydream, to make sure that we can support you to get your games to those platforms. So with Office we have a very close relationship. And to integrate is super simple. You download the SDK, you plug in the hardware, and you go in Unity, you click a button, and we're going to see that later on. You click the button, support VR, and it's done. That simple is the integration. Now in the past, when you did AR, VR in Unity, when it was not integrated, you have two screens, two cameras in your scene running, and of course that creates a lot more draw calls, and it's more costly to render everything, 2 times like shadows, or 2 times occlusion culling, and that's something with the native integration that we changed. You just click a button, and then that's all optimized for you. Now, we also support the Samsung Gear VR. Who has tried that? Everybody in Korea should try Samsung Gear VR. There's no excuse. Okay. No, this is really cool because of our strong relationship with Samsung, and there's also optimization being done. And here are some of the new examples, and all Gear VR games made in Unity. So to get started with the Gear VR, you download Unity for free, you download the Oculus SDK, and you install your driver in Java. That's about it. And then in Unity, you click the button, export to Gear VR, basically, and it's done. Super simple. Of course, there's a lot of important settings. I'm not going to go over them. But like say enable multi-threading, you're going to make sure your anti-aliasing is set to that. You're going to make sure your rotation is set to landscape left. Well, this is the beauty. You don't have to do anything of that anymore. Because thanks to our partnership, we work together, and then when you click the platform, automatically when you say select VR and you build to Android, automatically all the settings are set for you. You don't have to think about that. Now, we also announced our relationship with Google, and we're fully supporting now Google Cardboard. Somewhere end this year, the native integration will be available. Currently, it's a plugin. You install an asset store package, say install an asset store package, and then you have the native integration. Of course, that's not native yet. And that's the optimization is not done. You render 2 cameras, but end this year, it will be just a drag and drop, a click in our settings, and it's done. We also have the full integration done for the Sony VR and the PS4 VR. It's hold it down, easy, just click, it's a drop down button too. Another very cool relationship that we have is with HoloLens. HoloLens is to see it in AR. We have been working very closely with Microsoft on that. It's a very cool device, you just put it on. You make things in Unity, and then you say build and run, and automatically goes to the HoloLens. There's nothing special to do. We did a lot of workshops together. We went around the country in the United States, and everybody got a HoloLens device. They put it on, played with it, and then we made all different games together and experiences and put on the HoloLens. I got lucky. I took 3 days of HoloLens with me, and I made all different experiences. It's a very unique experience, but I think AR will be way bigger than VR. And it's something you can put on and experience right away with the real world. It augments and it creates a better life. We also have a relationship with Vive. It's ATC. This is for the Holy Room Scale VR. What's really cool is that the relationship with Valve, that they actually provided tools to us to make it easier to do, and they placed them on the Asset Store. Anybody knows the Asset Store? Raise your hand. And the Asset Store is a store that in our software you can buy art content, scripts, or you can sell them there. Anybody who sells on the Asset Store? No? You should really sell, because the top 20 are making easily $20,000 to $60,000 a month. I know that's not much money for you, but you could use it maybe. And because of that, there's a lot of Asset Store packages now. People are making VR Asset Store packages of gaze controllers, all different optimization things for you, for head tracking, to download. Of course, there's a lot more than just our official partners out there. There's a lot of different VR hardware coming out from all different directions from the world. From LA, different studios, Brazil, China, they're all making it. And the benefit of being a partner of Unity, of course, is and fully integrated, is the optimization. So here are a few points that really talk about the optimization benefits, and when you have native integration. And simple things like automatically matching the field of view of the camera with the hardware field of view. Handling distortion and the reprojections. And it's something very complicated, but Unity takes care of that for the native integration. Okay. But one of those optimizations is really beautiful is occlusion culling. The occlusion culling is only rendered in one eye and then automatically shared in the second eye. This reduces heavily your calculations. Now another thing that we do is shadows. We render in one eye and we share in the other eye. And this is what we call a single pass stereo rendering. And later on we're going to learn more about that. We support all the platforms from, of course, with Oculus window. Currently there's no, you cannot run Oculus on a Mac computer. From Windows up to 70 is all compatible for the VR and AR. From Android, starting up from Lollipop. Make sure your graphic drivers, you update them all. And that's sometimes a demonstration, sometimes people say it doesn't work. Okay. Now, we recommend the configuration to set in Windows to enable Direct 3D 11. Because then you can expose some of the more VR rendering possibilities. So you can make really nice VR games. And these settings also set to linear space color. And linear space color is by default in Unity is gamma. And this is something that Unity is a bit strange in that. What a lot of software developers do is they put their software settings all to the max. Unity is just the opposite. We put everything to the bottom, to the lowest. And why is that? Because it's easy to put everything to the max quality, but then you put it on hardware and then you're disappointed. And you have to really think what is the minimum spec that it can run, and the minimum settings I can make it work with. And that's why we turn off the linear, we put it to gamma, but if you do it for VR, change it to linear. Okay. Now, when you make VR games, one thing is that you have to hit, especially in the Oculus and the Vive, that it needs 75 frames a second, definitely. But I would do actually higher if I can. And this is required. If you don't do it, it's going to be laggy and you're going to get sick. And you rotate your head, but the frames are not updating fast enough. And then you get really sick. It's the same for mobile. Make sure you hit 60 frames a second. Okay. And that's why we advise, like, on technical things, is like make sure you bakelite and optimize. Okay. Now, with our VR, we also provide like a lot more APIs, and from the Unity engine.vr. And the cool thing is like, hey, we have device settings. We can check which, you put it on, it automatically can detect which hardware, which VR hardware you connect to it. And because this is the beauty of Unity, you can do multi-platform VR. You make your application one time in Unity, and then you can export it to all the different VR hardware. So to make sure that you can learn this all, that's why we provide on our website and on our asset store demo packages. You can download them, and then on our website are full articles and movie files that really take you through those processes. What did they do to optimize it? How did they make it? We have several examples, like a flying game, a shooting game, but I highly recommend you to check this. Okay. Now here, cross-device settings, and this is really beautiful. And this is a bit sub-technical, but the VR settings render scale allows you to scale the size of the texture, of the eye texture. And what I mean with the eye texture is the texture that is actually deformed and that is projected on your eye, and then you can see. And because you have your camera, and then it becomes warped to fit with the profile of your eye. Okay, and then you can scale. Why is that? Well, it can be set then different hardware settings, any different like the Oculus or for the Samsung Gear VR, it can be adjusted. You can actually do it during runtime, but I would not do it during runtime to change that. Okay. One thing I want to point out also is that VR is not new. VR exists already a long time. But most of you probably you're very young, so for you it's maybe a long time, but for me, a very old man, not so long. Okay. But one thing that we said is a gap of disappointment sometimes. Everybody thinks that tomorrow everybody will use VR games or AR games. Well, it's growing the market. It's not because of tomorrow will be a thing. But we see a significant growth, and it's the first time that the quality is there, the tracking is there. In the 60s, it was, in the 70s, in the 80s, it was not there. Now it's the first time. And that's why people started to make all plugins for it this time. In the past, it was not accessible. And I always find it funny to see those kinds of images. But that's over. And that's why the gap of disappointment, I think it's over. Okay. Now I want to give a little bit technical advice also, and design advice. Okay. So in the don'ts and don'ts from mobile, there's a lot of things we can talk about on the very technical side. Okay. But I don't want to go really over that, and I like more the design advice. One is that you want to keep your vertex count as low as possible, but of course, still in this game you want to still make it look nice. But your draw calls is significant. But in Unity, a lot of people look at the draw calls, but that's not exactly correctly true. I will show you later on what you should look at. Is the draw calls could be the same, but what happens is the cost is the change of the draw calls going to the next frame, and that's what I want to show something also. And this is really incorrect, I found. One I wrote today, that's a long time ago, we got this information. Use high-rate textures to compensate for low polygon. Well, over time they have now shown that they actually model a little bit of higher res in VR than a mobile game. The reason is that the normal maps don't work. So they actually model a little bit higher res than it is. And this is something that some of the, especially the company Alchemy, who made the game Job Simulator, they had to start to remodel everything. And they were counting on a normal map, they were counting that people will understand the shapes of lower res. They actually model a little bit higher res. Of course, and usually the very common things like object pooling, making sure you don't have a CPU spike, because then you drop your frames and then you get sick. Okay. That's why use a profiler. And who has used a profiler in Unity? Nobody? Okay. In Unity there's a profiler, window profiler, and then you can see all your performances. Okay? Especially the GPU and the CPU, that's where you can analyze everything. And that's where you can actually then see if you that you have to optimize, where your bottlenecks are. Okay. So it's really not worth it to have frames dropping, to have a little bit laggy game, because if you have your device on and you rotate and it's a little bit laggy, you get sick, because your brain is saying you look to the right, but the image shows you look in the front. That's why sometimes cartoon works, and that's why Job Simulator. Anybody has played this game? One. So Job Simulator is a little game that it's like there's no jobs left. All the computers took over the jobs. and you have to learn how to do a job again. It's a really fun game. And my daughter of 9 years old plays it all the time. Over time, in this presentation, I'm going to talk more about it. But they chose a cartoon style to make sure the frame rate worked. But what's really interesting is that the people, when you play the game, you're fully connected to it. You feel the presence, what we call. And over time, I will explain a lot more about presence. But I'm going to give a little bit more design advice, and that's what I like, really. Okay. So, be nice to your players. Okay. So, what does that mean? Okay. Yeah, that's true. Those things happen. Okay. The thing is, we are game developers. If you make games, you really get used to it. You put the device always on, and you understand how it all works. Okay? But if you are new to it and never done VR, you really think it's going to be real. Okay. There's a lot of things to our brain that happen there. So don't make it scary. Make them understand where the space is. Okay. And this is something that is a new word that's becoming is VR legs. Anybody heard of VR legs? Okay, one person. So the VR legs concept is the fact that hey, when you put it on, you don't see your legs. Okay. And for some people, that makes them scared, or they don't know how to react. They don't feel the presence. Okay. And if you use VR a lot, you know that exactly put it on, you don't see your body, those things don't work. But if you're new to it the first time, hey, you have to understand very clear what the game is about. And because this is what you want to avoid. The moment I nearly threw up at the VR demo. Hey, this was a reporter who went to CES and he got so sick. Okay. No, the design process is quite different from a regular game. First of all, is you're dealing with a whole range of people, with height even, the abilities, and that's wholly different than the past. Okay. A nice example is here, job simulator. I was early involved in the beta. Okay. And then really funny is that my daughter wanted to play it. It worked. But then my niece, who's 3 years old, was so she wanted to play it too. So she puts it on, but she's not as high as the table. So she can't see what's on the table. So how do they play the game? My daughter puts it on, she grabs all the objects and puts them under the table, so my niece could get them. So that's why they made a different version. And then you could say, okay, I'm under that height, and then they put the table lower. So it's all things you're going to have to think about. One of the other things that I had to think about in this process was the controllers. They put the controllers on the people, and they get so absorbed in the game, and on the end of the game, guess what they did? They put the controllers on the table, but there's no table, it's a virtual table. So they dropped the controllers on the ground. So they had to, in the game, make a reason that on the end, you have to put the things back on the floor, because otherwise they drop on the ground. Okay. So another thing that we saw is that people wanted they bring in the 3D models in Unity, but they don't think about the scale. And they bring it from 3ds Max or Maya, and then they scale. Well, when they select the camera, and the camera is most of the time connected to a parent object, they scale that. But what happens, it scales also the distance between the two eyes. And that became very nauseating for a lot of people. And so if you scale, don't do it. Make sure you understand the scale of Unity, that 1 unit in Unity is 1 meter. And don't change that. Right now, there is no API to set the interpupil distance. Like, you can define the distance between the eyes, but right now we don't have it in Unity. This is something we will be working on. Okay. Okay, this is also sometimes what we hear. There should be short experiences, from 5 to 20 minutes. Well, I think that's changed a lot, because I play now sometimes my VR games for 2 hours or an hour and a half, but then I get totally sweaty here. It's really soaking wet. So, but if you do like more mobile, where you don't have head tracking, then the experiences are shorter, because it's harder to sit this. Now, one of the things, Ropardo, you might have heard of that name in the past. Ropardo made a little game called, everybody knows Ropardo? He made Hearthstone. Nobody knows Hearthstone? Okay, I hope so. Okay. And he made like another game, World of Warcraft. You might have heard of that game. Okay. But his biggest advice was always, if you create a game, create it for the platform. Don't take an old game and convert it. Like a nice example of this. When the first mobile games came out, a lot of people were integrating the touchpads on the mobile phone. Virtual touchpad. It didn't work. So they removed that and really designed the game to be really touch instead of virtual touchpad. And here's a nice example of that. How they did a very good integration, but really had to change the game. Temple Run. Temple Run was a mobile game. It's in third person. But for VR, they went in first person. You're walking forward. And what they did was a big change. Like when you look backwards, you see the monster. But what they've done is they make a shadow in the front. So that you have the shadow from the monster in front of you. So you really have the feeling that the monster is running behind you. Otherwise you didn't have that. You only have it in third person. Other things that we see that sometimes were rejected is because they didn't think about the logo that comes up, the Unity logo or their logo for the company. They didn't put it in VR. So if you want to submit to the Samsung store, you must make sure your logo is in VR. Okay. Now, when you do a pause in the game, you must make sure that the camera still rotates. Sometimes people pause, and then they pause the camera. Well, what happens is when you pause the camera, when you rotate your head, the camera doesn't rotate, and you become nauseous, you're going to get sick. Okay. Now, also it's when you go to another scene. How you do that? And here's a nice example is this. When you look and you want to go to a certain area, notice very fast, they're going to do a little fading, a little blink. See, you saw the blink? Okay, they do that because, and they're only going to explain more about that, but it's a transition. And when you do transitions to a new scene or to a new area, fade it. Do a quick black, because otherwise it's like I'm standing here and a second later I'm somewhere else. It makes it difficult. Okay? So some people use mechanism and state machine behaviors to make this. Or like they do a blinking with an animation of two quads to make this happen. So like, I'm going to show it again so you really know, okay, if you do a little bit of blink, it helps you with the teleportation aspect. And when you look at it, and then you blink, and then you're there. Okay. Now, another thing is that when we see in PC games and games before is all those menus here, the UI, and that has to be totally changed. And when you do AR, we try to put them in front of you, not on your eye. That's why the design becomes totally different. You're designing the UI around you in the world. Now, there's a few things about that. Integrating as part of a real object in your world. I'm going to see some examples of that. Now, my eye, and later on I'm going to explain that, has a very good depth perception and sees very good between 1 meter and 3-4 meters. After that, we start to lose depth perception. I'm going to explain that later. And that's why we put the menus nicely in that zone, in that area, and to really bring them out. But what we also saw, sometimes people put those buttons in the scene and you have to look from left to right. It's even in AR, when you would have to look like this in order to read something. It's not working. So put everything in a camera viewport so you can actually see everything. Okay. Nice example is like, who has played this game, Roman 360 on the Gear VR? Okay. I encourage you to go play games at night. Okay. But what they've done is they integrate, like here, this exact nice example is the amount of light we have. They integrate it in a 3D object instead of just an image somewhere with the points. And they integrate it. Like here, this example too. The timer you have in the game. How much time you have left. And what they do, they integrate it in the scene, like in the real world. And that's why we see now some of those VR games going up with very nice designed UIs, but in a 3D world. Now, if you had a game in Unity before, you create those buttons on the scene. Okay. Now, how you convert it, it's really simple. You select it and you change the properties, make them in a world, and then they become 3D objects in your scene. So it makes it easy. Now, what we also see is a crosshair, and this is like a little dot that shows you where you're looking at. Okay. And later on we're going to see more about that. But what we've seen is that some people put a trail behind it. Some people change the scaling of that little dot based on the distance they look. If I look closer, it becomes bigger. If I look far, it becomes smaller. So to give that dot also 3D information. Okay. Another thing that what we see, and they copy paste this from the Oculus manual, is acceleration or ups and downs changing. Okay, they don't happen in real life and to your body, you don't feel it. But in the game, like when you fly around or go up or down or drive, how to deal with that. And here are some nice examples. Times of Space is really one of the early ones, but you fly around in the space. And of course you would be very, very sick because your head is not, your brain is not saying, your brain is thinking that you go upside down or flying left or right, but you're still sitting still. And that's why they created that virtual body there to help you stabilize your brain. Another example is Lucky Tail. Nobody has played Lucky Tail here? Okay. One person? Two? Okay. So what they've done is when you walk around, this fox jumps around on the planet. When the fox has to climb up or climb down, the camera moves very smooth, a little bit delayed on it. So it helps you to understand, okay, he's climbing, but then the camera falls a little bit smooth. So it doesn't follow exactly what it does, and otherwise you get sick. Okay. Now one thing that we have to understand that the player can look at any direction. And especially with the Gear VR, there's no cables. That's why they modeled the background. That's why they modeled a monster coming after it. But here it becomes super interesting in this one. This was done for the Vive. The Vive has a cable. So what would happen if I keep rotating? You hang yourself or you trim yourself. So what they've done, and that's really smart in the design, is when you look forward in the game and you have to pick up something to the left, okay, you go here, you pick it up, but then they always made a reason that you always have to come back in the front to pick something else up before you go to there. So the design was really thought out to make sure you don't get strangled. Okay. Now also, in this game, what they've done is instead of like just looking down, they made sure there was reasons to look up in the game, so you see that the dimensions of everything. It helps you. Otherwise, if you just would focus here, you would never understand the space, the size of everything. That's why they made you look up somewhere right. Okay. Now, the wow factor. What I mean with that is, if you're put on the headset, they want you really to be integrated and say, wow. And how does that work? Well, we have 5 senses. We have seeing, hearing, touch, taste, and smell. Well, we can only focus on hearing and seeing and touch at the moment. We don't have the other possibilities like to make smells yet in our games. Okay. So in seeing it's actually super easy because we have the stereoscopic view worked out. We see three eyes, and it's on every VR platform the same to see 3D. Now on hearing, it's a little bit more difficult because companies are working on spatial audio and the Doppler effect. And here is how fast you can test from an audio. Do this when you play a game. If you have a fly flying around your head, do you hear it? And do you know what exactly the position is? But there's a big difference also in some audio technologies. They have from left to right. But it doesn't mean you can hear the differences if the fly flies over your head or in front of your head. So that's all things in technology they're still working on, and some technologies work on within that. Okay? But having that audio gives a sense of presence. That's why what we see in the advices that we say to audio people who make VR games, don't forget about the audio. It's the image plus the audio. Okay. And it's on the same on every platform, so that's why it creates that presence. Okay. Now, touch is also important. But it's very difficult because we don't have really touch devices yet that will feel a surface or anything. But we want to interact with our objects around. Look at this. If anybody who puts an Oculus on or a Samsung Gear VR, the first thing they do is they try to grab. But they can't. Okay. And movement is also very difficult. But we're still learning about all those things. So the difference is that it's different on every platform because all the different ways we touch. And we have, and especially in mobile, we use gaze. We're going to talk about that. Carbon is one touch input when they click the screen. But the controllers and gesture are already there, depending on the lead motion. Where some people have put the lead motion on top of the Oculus, and then they see the hand in 3D there too. Okay. And Vive has the 3D tracking. So there's a lot of different controllers out there. So it becomes really interesting to familiar input, not unfamiliar input. Here's a nice example. If you play Lucky Tail, and you put in the Xbox controller, you play with it, well, some people are totally not familiar with that, and they don't even see it. They have to blindly find the device, and then the game says press the X button or the A button, but a lot of people don't know where it is, so it makes it very difficult if you're not familiar with the hardware. Okay. And some of the controllers have a lot of buttons. If you look at the Vive controller, you really have to go to the tutorial to understand where all the buttons are. Skip this. Okay, so here's a nice example of those buttons. Are those, when you see the controller in the Vive, when you put it on the first time, you actually see the same controller on the ground in 3D, and you're holding it. So it makes it super easy to adapt to that. With the Oculus, the problem was for me, well, I put on the Oculus, but I don't see the devices. I don't see the Xbox controller. The touches are there, I got up here, but it's really difficult. But in this game, for instance, it was super easy. First, you see them as regular controllers in VR, and when you picked it up, it became the bow and the arrow. So it makes it easier to convert and understand the second time, okay, my controller is actually the bow, and my other controller is actually the arrow. Okay? And here, that was super interesting done. What do you see here? Okay. No, if you play the game once, you have to pay attention to it. The moment you pick up an object, they remove the hand. And they did a study. How many people noticed that? Almost nobody noticed it. When you grab something, they actually hide the hand. Because they want to make sure when you hide the hand, that you actually see the 3D object fully and not obstructed by the object. But oddly enough is that nobody noticed that. Okay? So when you make VR games, you're really going to think about which input device you're going to use. And then design around that. Now, one of the strengths is our neck. It's a very good control system to look at, the gaze. Now, this is something also is confusing sometimes. Some people see the gaze cursor as an eye controller. No, the gaze is pure locked on your neck. We don't have eye controllers yet. Now, if you use a gaze controller, I'm going to show that then interactively here. And we look at where are we looking at? How are we going to see where we're looking at? Can we interact with that object, and how do we interact with that object? Okay, and in the hands-on example, I'm going to show to do it, and we're going to discuss that. But here, that's an interesting kind. Can we interact with that object? When the guys from Alchemy made their game, everybody, when the first time, they wanted to pick up all the pots and pans in the game. And what they did was, we don't want them. We don't want that. So they removed all the handles of the pots and pans, and nobody interacted anymore with them because it was like a sign, you cannot pick it up. Okay. One thing I also want to point out is this. At Unity 5.4, we have now a lot of image effects. And we have depth of field, tone mapping, vignette, all those things. Now I put them in red to say don't use them. Don't use a depth of field. Because depth of field doesn't exist in real life. Depth of field is only a one image and one eye input effect. It doesn't exist in real life. Lens flare doesn't exist in real life. And the SSR is too expensive to do it. Blur, template AA are still costly to do. But definitely you can use Loom, tone mapping, and vignette. They work in VR and are affordable on the GPU and CPU. Now, before I go to the technical aspect, you can take. I really encourage you to check out those games, and Lance and all those different games. Those are my favorite games I play. So if you want to see some really good games, play those games and think about what I just all talked about. Okay. Now, another thing that I really want to point out is this multiplayer. Okay. In the 80s, almost every PC game was a single player. Now, more than 80% of PC games are multiplayer games. I strongly believe that will be the same with VR. Right now, VR is in a lot of cases a single person experiences. I have the luck to play some multiplayer games in VR, and it totally changes perspective. We were both in a different location, you put a headset on, and I turn and I see my friend, a virtual face next to me. When I spoke, my mouth was not opening, but it was just a little bit color changing, flickering. When we played ping pong and badminton and a shooting game with each other. And I think that is totally changing it. That's where the biggest market will come, is the social aspect of VR. It doesn't have to be in gaming. Okay. So what I'm going to do, I'm going to go on to the technical part here more. Okay. Let me open Unity. Okay. Can I continue? Can I continue? Like 10 minutes. Is it okay? She's my boss. And every morning when I wake up, she's like. So here in Unity, when I press play, okay, what I want to do is I want to recreate a little game and I address a few things in there. It's a little game where I have to take that chip and I'm going to try to get that chip into the machine here. Okay? But, okay. I'm just going to check if I can get the resolution a little bit higher here. Okay. Let's see if that works. Oh yeah, much better. Okay. So, I'm going to do a new scene here. Okay. So, the first thing I do is put that prefab of that level in there in Unity. The scenery. Okay. And I'm going to delete the line. So, I have here a scene in my game. Okay. And I have a camera in my scene. So, I'm going to take that camera, I'm going to place it up here. Okay. Maybe place it here. Okay. Now, one of the first things I want to have is I don't want to always file build and place that, build it on my device and I look at it to test it. I just want to quickly on the fly be able to test here. But when I press play, okay, it doesn't work. I cannot rotate or anything. Now, when you're going to go make VR games, the first thing you're going to do is in the build settings, the player settings, and you're going to go here. You're going to activate virtual reality supported. Okay. Then, this is the beauty here. You have your drop down, clicks plus, and then you can say which hardwares you all want to attach to it. That works for you. Okay. Now, this is the most powerful feature in 5.4. Is the activation here of single pass stereo rendering. When you click this, it automatically makes sure it shares the shadows and does a draw call optimization in one eye. So everything in one eye is shared with the other eye. And this gives you a huge improvement. And with some of the games we saw a 70% improvement on that. Okay. Now my lighting, I can bake it here. So I'm going to put it maybe to just a little bit lower to bake this. Okay. And build. So what we're doing now is we're converting the light information to a texture. So instead of having real-time light information, we want to convert it to textures. This is also for optimization done. Okay, but I have my main camera now here. My main camera rotation is now totally controlled by my VR input. If the camera, my rotation moves. So, I want to simulate the rotations here in the game. How do I do that? Well, I have a little script here called here camera editor control. It's a little script. Okay, I'm going to open it. Okay. Come on. Okay, here. It's a little script that basically I'm going to use my mouse controller to where my camera will look at. But here, this is the most important thing. We're only going to run that in the editor. If it's not in the editor, if I build it, destroy this. Okay. So now I can press play here. Okay. And I can look around with my camera already to emulate how I'm going to look in VR. Okay. The next thing that I want to do is be able to move around with my camera. I want to look at a certain area. Okay. And I want to teleport to, let's say, that bridge in the game. Okay. What I'm going to do, because my camera cannot be moved anymore, impossible, because it's fully locked to the VR hardware. So what I'm going to do, I'm going to create an empty object, okay, and make my camera a child of that. And this object, okay, and then I'm going to make sure that I reset my camera here, reset position, okay. I'm going to take that object, bring it up, and place it there. This is an object, I'm going to call it player maybe. Okay. This is my player. That is an object that I'm going to use in code to move things around. Otherwise, my main camera is locked. Okay. So I'm going to add here a little script that I'm going to use, and it's called player mover. Okay. It's a simple script that basically I'm going to look at the raycast. So here, if I press the fire button, tap on my Samsung Gear VR, tap on my phone, or the Xbox controller, or one of the controllers on my Vive, then I will move the position of my player to a certain area. So I'm going to do this, look here. My player, oh sorry, the script has to be on my camera, that's how I designed it. So add a script, player mover. Okay. Now it can only move when I use a nav mesh to define where I can walk. So I'm going to go to my navigation, I'm going to bake this. Okay? And the blue area is where my player can walk around. Okay? So that way I prevent walking into the fence and walking on the bridges here. Then I just walk where I can actually walk as a human being. Okay? So my player, I'm going to go back here to the inspector, and I'm going to say use the ground for this. Okay. So when I press the play, and I look at a certain area, and click, I go to there. See, look, you're going to look at the windmill, and I go there. But it's a little bit problematic because I don't actually see exactly where I go. That's why we're going to use a reticle. Okay, and we're going to use here, I have here a little object, and I'm going to look at, when I look, that object will move with my eyes, and when I look at that, then I know exactly where I'm going to go. So look, I can go here to my camera and say use that reticle. Okay. So, okay, let's maximize this. Let's play. Okay. Now when I look at a certain area, and I see exactly where I'm going to go. It helps me to understand, okay, you're going to go to there, and I click there. Then you go to the beginning of the bridge. Where is it here? The bridge. Click, and I'm there. Okay. So that's why we use reticles. It helps the player to understand where to go. Now you might have seen that this reticle, okay, otherwise, that this reticle was a little bit damping on. But what we did, we put a little script on it, where we do lerping, so it damps it out. So otherwise, when I look and I'm a little bit shaky in my head, then it always moves really fast. So I make it a little bit smooth, so I can follow it with my eyes. Okay, because remember, it's not my eyes, it's my neck that everything is attached to it. Okay? That's why we have a nice smoothing here. And when I look at an area, you see, when I look to the left, and that little dot comes a little bit later. Okay, now another thing I talked about is when you move around, that you blink the eyes a little bit to teleport. But there's different ways you can actually do it. Okay? In this case, instead of blinking, I'm going to do some smoke. I'm going to make it white. Look here. I have a prefab here of a teleportation effect. Okay, I'm going to put that here on my camera. So look here. And what I'm going to do, I'm going to simulate this one. See? Look at the camera here. I'm going to simulate this. So it helps us to teleport. So each time I look at a different location, I'm just going to quickly play that system. So I'm going to go here to my player, my main camera, and I'm going to take that teleport effect and place it there in. So now, when I press play here, okay, and I'm going to click to there, hey, stop playing. Yeah, let's see why. The teleport effect is in there. Yeah, it's there. Main camera. Okay, display. Ah, no, it's working. Okay. See, now when I click, so I'm gonna go to that bridge. I do a little blinking, and I go to the area. Click there, and I understand where I am. It helps you with teleportation. Okay. Okay. Now, look, I'm gonna not fully make the game here, but one thing I wanna still point out is this. I'm gonna take the sheep here. Okay, you saw the sheep I was walking around. Okay. Well, we have here a 3D object on top of it. Okay. What we want to do is we want to have a name on top of that. So I look from any angle, I can see the name on there. Okay. And normally what we do is we create here a canvas. A UI, a canvas. Okay. And then we have here the canvas means like our text on top of the screen. So look, I'm going to create now a text for it. UI text. Okay, we see the text here is very small to see, but that's our canvas. Okay. Or we can make the canvas much smaller. Okay. Now, that's I call it a canvas projected onto the screen. Now we're going to make it in 3D. How we do that? By here. Instead of a screen space overlay, we make it a world one. Okay? So now this canvas, we can actually make it smaller here. Okay, maybe 50 and 50. Okay, and the text, I can move it in there. And I can take that canvas and put it on my sheep. Okay? So I can reset position. And I go to the canvas here. Okay, and then there's my text. Okay? But I can take the text. And then I can make it smaller, of course. But the beauty is now, look, I can rotate this even. Okay? So I can make a script that looks at somewhere. So look, what we're going to do is I made a prefab of that. I have here a prefab. And I have a nameplate. Okay, I'm going to drag on my sheep. Okay, so what I did, I put exactly the same, and I put here the, okay, I put here the text, and it's in 3D now. Okay, it's super optimized. So the nameplate here, okay, I can change the name to, say, Daphne the sheep. Okay. Okay. And then I can say, make sure that it always look at the player. Okay. Okay, so now look here. This is the beauty of those UIs in Unity. So you see, if I click here, I see the text always. When I go here to the other side, and Daphne is coming to me here, see? So I click from there and I see it. Okay. So, so you see that in Unity, to make VR games is actually simple. Then you go to your file, build settings, and you play your settings. You make sure you put your virtuality on. You pick your hardware you want to support, and you activate single pass rendering for the optimization. In order to make sure that you can rotate the cameras and emulate it in your scene, And just add a script to it, play a mover script. Okay. Another thing is think about teleportation effects. And if you walk around, okay, make sure you have an object above your camera because the camera is locked to the hardware now. Okay. And you use canvas, that's world, and to integrate it. And here's my canvas here. My nameplate is a 3D canvas. So there's also here is the dynamic pixel, and this is really about the quality. So look at that, and it's really hard to see in the smaller one, but if you have big text, you can nicely change the crispness of your text. And you can see if I put it too low here, my text becomes crispy here. When I bring it up, and I can actually sharpen the text. Okay? And this comes at no cost, and that's also very important. And then the last thing you do is just plug in your hardware, file, build settings, and then you can click, okay, I'm going to switch for Android. You say build and run, you plug in the device, and you put in a Gear VR, and you're done. And if you want to do for the Oculus here, the only thing you put it here, and then actually you can also press play here, and when you have an Oculus device attached to it, you look around, and the camera rotates, so you can directly play it there. Okay. Now, with Unity, we want to make also a step further. Okay, is that we want to have the editor, this VR and VR. What does that mean? In this year, when you put on your Oculus or your Vive, you will have a button VR, and you will see that in VR. You will see everything you see here, and then you can use your controller, your Vive controller, to say, okay, place my sheep there. Attach that script to it. And make the platform and scale it. Place the light there and rotate it. So that you do creative VR directly in VR. Okay, let's take a quick break. And then I'm going to talk about this. Quickly explain it. The thing is that a lot of people, I'm going to do an exercise quickly here with you. Look around. Okay, you see everything in 3D? Now close one eye. Do you still understand the space? Yes. So that's what I'm going to explain why is one eye in VR so important to understand space. Okay. Thank you.